Hi, this is Elena, and I'm going to be presenting our work, Borrowing or Code Switching, Annotating for Finer Grained Distinctions in Language Mixing. This is joint work between Konstantin Lignos from Brandeis University and myself at UNED University. So what we're going to be covering in this work is the differences between code switching and borrowing. So we'll start with some definitions on those two topics. I'll present the task that we did, the data set that we created, and annotation guidelines for that data set. I'll present the modeling results that we got, and we'll see the conclusions. But to begin with, what is code switching? Well, code switching is basically the process of alternating between two or more languages in the same discourse. Let's say, for example, that we have a speaker that is bilingual in English and Spanish. So this person may alternate between these two languages in the same sentences, in the same sentence or in the same discourse. For example, sometimes I'll start the sentence in Spanish y termino en español. So part of the sentence is in English, and then there's a switch in the middle into Spanish. So code switches are these fluent multi-word interferences that combine more than one language. Code switching is something that happens among multilingual speakers very frequently. So in terms of NLP approach, code switching has become a frequent NLP task over the last decade, and we've seen several data sets, shared task, and a benchmark revolving around code switching for various language pairs. The task of code switching identification has consisted basically in identifying the language of each token in code switched utterances. So for example, let's say that we have a social media message that is code switch, that contains a code switch. So it would consist, the task would consist in detecting and identifying the language of each token in that message. In that sense, this has been framed as a token level annotation task. So every token in the sentence receives a language identification tag. So let's say, for example, that we have a collection of code switch tweets. So part of the tweets are in English and in Spanish. Tokens in Spanish will be labeled with a Spanish language identification tag for Spanish, and similarly, the tokens in English will be labeled with a language identification tag for English. So besides the language 1, language 2, or in our previous example, Spanish and English labels, there have been more labels that have been proposed for annotating code switching data sets. So we've seen some data sets that contain the label ambiguous for words whose language is difficult to determine, even if it's in context. Other for tokens in languages other than the language 1 and language 2, the main languages under study. Mixed for interlexical code switching, which means having a word or a token that combines morphemes from both languages at the same time. So it's an interlexical code switching. The token itself, it's code switched. And NE for named entities, and none or N for punctuation marks, emojis, Twitter mention, things like that. Basically, this repertoire of labels has become the usual tag set in code switching shared tasks. So this would be an example of two instances being annotated for code switching. So in this first example is I got it, but prefiero usar mi del para cosas sencillas. Part of it is in English, part of it is in Spanish, and the English tag labels the English tokens, and Spanish tag labels the Spanish tokens, and we also have a named entity for named entities and things like that, and for punctuation. Or the second example, adios, I'm tired. Adios is labeled as Spanish, and the rest of it, I'm tired, is labeled as English. So the thing is, let's say that we're interested in creating a data set that is rich in code switched utterances. Given an utterance that is mostly monolingual, can we assume that any token from another language is going to be a code switch? Or could it be something else? Because after all, language mixing can happen in many other scenarios and can happen for some other reasons that are not necessarily a code switch. What could be that other thing that is not necessarily code switching, but that involves language mixing? Well, basically lexical borrowing. What is lexical borrowing? Well, lexical borrowing is the incorporation of words from one language into another language. So for example, in Spanish, we sometimes use words that come from English, and here you have some examples. Words such as podcast, app, online, crowdfunding, spin-off, fake news, big data. All these are words that are English words, but that we use sometimes in Spanish. Lexical borrowing is a type of linguistic borrowing being a broader concept that involves reproducing in general in one language patterns from other languages. And in a sense, borrowing and code switching are very close and are related. And in fact, they have sometimes been described as a continuum. There are some differences, though, between lexical borrowing and code switching. So code switching is something that is done by bilinguals. And because the bilingual person is switching from one language into another language, the spans of text in each of its languages will comply with the grammar expectations of each one of those languages. And by definition, the code switches won't be integrated into any of these languages. So won't be integrated into the other language. So if you are speaking in Spanish and switch into English, then when you go into English, your utterance complies 100% with the grammar expectations of the English grammar, and there's no expectation of that English code switch that will eventually be integrated into Spanish or anything. You're just switching from one language into another. Lexical borrowing, on the other hand, is something that is not done only by bilinguals, but also monolinguals. And this makes the borrowings that are being used by monolinguals will be compliant with the grammar expectations of the recipient language. So if a monolingual of Spanish uses an English word, an English borrowing, the speaker will make the borrowing comply with the grammatical expectations of the Spanish grammar. And in fact, the notion of a borrowing being foreign can sometimes be forgotten, and eventually the borrowing will become integrated into the recipient language. So let's say that we have this example. This was the instance that we saw before. I got it, but prefiero usar mi del para cosas sencillas. This is plainly a code switch. We have part of it in English and then the tweet goes into Spanish. But so that would be like a true code switch. But let's say that we have the second example here, which says, intentando comprar online uno de los nuevos discos duros que sacó Samsung, pero qué lata tener que rellenar tanto formulario. The only word there in English would be online. But it seems unlikely that this is an example of a bilingual switching between languages. This looks like something else. This looks like a monolingual using an English borrowing. And in fact, if we have a look at the code switching data sets, the frequent or most used code switching data sets, what we find is that the most frequent tokens or code switches in those data sets includes words like internet terms such as LOL. It's unlikely that these words represent a bilingual switching between languages. This could also be monolinguals just using borrowings. So if what we want to do is gather or collect a corpus that is rich in code switching, then just having a collection of tweets that are rich in whatever they are, other language inclusions, might not be enough, because these other language inclusions could be borrowings. And in fact, Poplak and Dion stated that this distinction between code switching and borrowing, it's probably one of the thorniest issues in the field of contact linguistics today. So with this in mind, what was the task that we accomplished? So we have that this difference between code switching and borrowing has been discussed and explored in the linguistics literature. But however, this distinction has not been implemented in NLP code switching datasets. And in fact, when we revised prior work, we were not able to identify like an explicit definition or guidelines on what should be considered a code switch or what should not be considered a code switch and could be a borrowing. So our goal with this task was to create an annotated data set that implements this code switching or borrowing distinction, develop annotation guidelines that could assist annotators and that could reflect on this distinction between true code switches and lexical borrowings, and also explore the performance of several transformer-based models for the task of predicting is this a borrowing, is this a code switch in a rich language mix setting. So the data set that we created was actually, we used an existing corpus already annotated for code switching. The code switching data set that we used was the corpus by Lignos and Marcus, which consists in 9,500 500 tweets, which amounts roughly to 200,000 tokens. It's a data set of tweets primarily in Spanish. So it's mainly composed of Spanish tweets, and some of these tweets may have an English inclusion. An English inclusion that might be a code switch sometimes and might be a borrowing sometimes. This data set was already annotated for code switching using the usual labels that we just saw for code switching. So it would distinguish between Spanish, English, other, and MDT, punctuation, and things like that. And what we did was we used this already existing corpus and to re-annotate it, implementing the borrowing versus code switching distinction. So our labels contain a borrowing label that the previous annotation didn't include. For recent borrowings, so words in English or other languages that could be a borrowing. Also, we kept the Spanish label for Spanish for Spanish sections, and English for true code switches and things like that. So how did we decide what was going to get labeled as borrowing versus a true code switch? Well, English words related to Twitter terminology, we decided those were going to be considered borrowing. So words such as tweet, follower, things like that. Also, technology words that are frequently borrowed, such as server, hosting, app, blog, things like that. All those words that monolinguals also used frequently were considered borrowings when they appeared in an otherwise monolingual context. We also use some lexicographic resources. So English words that are registered in Diccionario de la Lengua Española, which is the general dictionary of standard Spanish. Words such as look, marketing, all these words are already contained in this general dictionary. We considered those that they were also borrowings. Similarly, English words that are already registered in Diccionario de Americanismos. Diccionario de Americanismos is a specialized dictionary that covers basically the vocabulary spoken in American Spanish. So it has a very good representation of well-established lexical borrowings from English that are used in Latin America. So words such as a man, nice, party, these words are registered in that dictionary. So we consider that those were also borrowings, not code switches. Similarly, English words that are the head word of an entry in Spanish Wikipedia. So let's say the Spanish Wikipedia page for whiskey has as head word the word whiskey. So that would be considered also borrowing, not a code switch. And finally, words that have English origin, but that were being used following the Spanish grammatical structure, such as noun, adjective, word order, then we would consider that a borrowing and not a code switch. So basically what we were aiming to reflect with guidelines 3, 4, and 5 is that if code switches are something that is done by bilinguals, if we have an English word that appears either in these two dictionaries or as a head word in Wikipedia, this means that this word is also used by monolinguals, not just bilinguals. So if any of these words appeared in an otherwise monolingual context, we consider that a borrowing, not a code switch. Similarly, because code switches by definition will comply with the grammar of the language in use, then if we have something, an English word that is being used following the Spanish grammar expectations, then we can't really consider that an example of code switching, but rather a borrowing. So that was the idea behind these guidelines. So we re-annotated the data set. After the re-annotation, these are the counts per label that we got. As I mentioned before, this is primarily a Spanish data set. So unsurprisingly, Spanish was the most frequent label. If you see here, there were 2,800 tokens labeled as borrowing, which is not bad, given that like these words in the previous annotation had been labeled as a code switch. But with the guidelines I just presented, this would be considered borrowings. And in fact, if we have a look at what were the 10 most frequent tokens per label, what we see is, again, unsurprisingly, in Spanish, the most frequent tokens would be grammatical words such as de que, so prepositions, conjunctions, things like that. If we have a look at the borrowings, the most frequent borrowings, we found words such as blog, post, web, followers online, things like that. And if we have a look at the most frequent tokens in English, so true code switches, what we found were also grammatical words such as the, pronouns, and things like that, which seems to suggest what we're seeing here are true code switches, not borrowings. Because if we compare these most frequent English tokens with the most frequent code switch tokens in prior data sets, what we found there were internet terms or other types of borrowing, such as LOL, which is not necessarily a good hint of something being a code switch, because it could also be used by my monolinguals as they are also borrowings. So once we had the annotated data set, we went for the modeling. We evaluated 4 transformer-based models on the data set. So the task consisted on predicting the labels we just presented. We tried multilingual BERT. We also tried Beto, which is a BERT-based model for Spanish language that is trained on a diverse set of international Spanish texts from different origins. So you see here open subtitles, global voices, United Nations. So it's from geographically and dialectically diverse set of texts. We also tried Roberta BNE. This is a Roberta-based model that is trained exclusively on data crawled from the .es website, the .es website being the top level domain for Spain. And this data set was crawled by the National Library of Spain. It's interesting because Roberta BNE, it's a bigger model than Beto is, but bear in mind that the representation of texts seen by the model is more narrow than the one seen by Beto. Why? Because the Roberta BNE is only seeing data from the .es domain. So it's only seeing text from Spain, whereas compared to Beto has a more diverse set of text, even if it's a smaller model. And finally, we also tried Roberta Twitter. This is an English model, Roberta based, but it was trained on Twitter data. So we wanted to see how well a model that had been trained on Twitter data could perform on the task, even if it's just a monolingual English model. And these are the results that we got. Just so the best 2 models were multilingual BERT and Beto, but just like multilingual BERT was slightly better than Beto in terms of F1 score, but we really don't have any reason to believe that one was better than the other, given that such a small difference. But what was interesting is that Beto performed better than Roberta BNE, like 3 points higher, even when Beto is a smaller model than Roberta BNE. And we suspect that this may have to do with the fact that Beto has been exposed to a more diverse variety of Spanish texts in terms of dialects and geographical distribution of the text. And probably dialects that also are more prone to code switching were included in Beto training data, rather than the type of text, which is very Spain-centric, seen by Roberta BNE. And the one that performed worst was the Roberta Twitter, which was a monolingual English model. So some conclusions to finish. We have introduced a new data set of tweets. These tweets are annotated both with lexical borrowings and Spanish-English code switches. The annotation builds on previous approaches to code switching, but the important thing is that it distinguishes between lexical borrowing and true code switching. This distinction has been pointed out and studied in contact linguistics before, but had not been implemented in code switching data sets. And finally, we have experimented with different transformer-based models for this task, and we have compared some results for this task. So here are some references, and thank you very much for listening.